I joined the BBC straight from university. I did a chemistry degree, followed by a master's, thinking I wanted to do research, and all that really taught me was I didn't want to do research. So I was lucky that I got onto the trainee engineer scheme, and then they sent me to Wood Norton for 3 months to kind of break my spirit and see if I was really wanted to do this. So that was a 2-year scheme, which you will hear more about actually this afternoon, because one of our current trainees is here to talk to you about it. So it was kind of training and time away from base learning, and then a lot of time on base going around different radio departments in Maida Vale, in kind of supporting journalists for a while, different areas, and then the master control room, which at the time was just the radio control room. And what that taught me was what I really wanted to do was be where broadcasting happened, be where what I did made a difference to what went out on air. And there's lots of people that didn't like that. There's lots of people that preferred to work in a recording area or something like that, where they got to do the beautiful balances and they thought about things and there was lots of time. And I really enjoyed the immediacy of what I did, then went on air within a few minutes.
I started off in hospital radio as sort of an engineer presenter type person, and then worked through commercial radio, building radio stations as a chief engineer. I built Classic FM, and then I went on to do something in DAB. I also became a presenter, which is kind of like a hobby, on Classic FM, doing a programme from home every weekend on ISDN. And my tech op for that programme, would you like to stand up? Whatever happened to him. So that's how we got into the business, and we're going to talk to you about the central technical area. You've seen the studios, you've seen some of the equipment in it, but as has been mentioned a couple of times, some of that equipment is quite noisy and some of it generates a lot of heat, and so you probably want to chuck that out of the studio. Plus you'll have a whole load of other equipment that connect you to the transmitter and do all sorts of other things. So we're going to talk to you about the technical area and the glue between them.
Yeah, so we're going to share most of this. So this is a enormous CTA, but obviously depending on the size of your radio station, they could be just almost a cupboard with racks in it. Obviously at the BBC we have many, many rooms full of technical kit because they're supporting all the TV studios, radio studios, etc. But as other people have said, you essentially want to get the noisy kit out of the studio, out of the place where you are, where the presenters are, the guests are, the people driving the show are, and into not only kind of to remove the noise, but also to put it into air-conditioned rooms that are suitable for equipment. So it's about what goes into them. So it's all the noisy computers with the fans. It can be the brains behind those desks that you saw in the last presentation. The codecs that we use, the ISDN that we mentioned earlier, the IP codecs, all of those things, mostly will all go into rack rooms. So everything you don't absolutely need in a studio or in a control room environment will be in there. So when we do the switching in the master control room, all the switches, again, they're in apps rooms, the network switches, the transmission switches, everything like that, they're all in the apps rooms behind the scenes, as it were. Controlled access, apart from anything else, so people can't just go in and start switching things on and off, but also in areas that we don't need to, so we don't have to have the kit with us. Much safer as well. And you want to say about that, Quentin?
Well, that's the sort of thing you'll see in a racks room. We've got lots of pictures of various bits, and we're going to show you some different racks rooms and some of the kit from different radio stations, so you can see it's all very different. But they tend to be quite neat places. If a racks room is neat, it means it's been well planned and well maintained and looked after.
So one of the things I was going to say there is this is one of the ones at BBC, actually, this is our radio network switcher, and then we'll go on a bit later as well to look at some of the kit in the other bays. But the white bits between them are partly so it's kind of space for air, but also we've covered the front of the gaps, partly so that we've got the cold aisles and the warm aisles to keep the air directional, so that every other aisle is kind of a cold aisle, every other one's in between are the warm aisles to keep the airflow around the kit. So
there's lots of kit that goes into these racks rooms, and also there's a lot of electrical power management, because this stuff takes a lot of power. And as somebody mentioned before, you might have the need for uninterrupted power supplies and generator backup to make sure that all this stays on air. And as you've said, security is important in racks rooms. It's probably the most secure part of a radio station, because you do not want the wrong people going in there and taking you off air or hijacking you and doing something else nefarious. So you'll have come across the term a 19-inch rack. 19-inch racks actually were standardized by the Americans in 1922, and a lot of broadcast equipment has hangbacks to the old telephony days. A lot of the equipment we still use today is actually based on telephone systems. So a 19-inch rack is 19 inches wide. The gap for the equipment is about 17 inches. I'm sorry, I'm old-fashioned. I can't do the metric stuff. And every piece of equipment is in multiples of 1.75 inches high, which is called 1U. And a typical rack will have 44 U units of equipment in there. Some will be 1U high, some will be 2, some will be 3. And you could fill your rack up and plan it. You can actually plan it on a spreadsheet, lay it out with 42 lines and decide where all your equipment's going to go. These days, some racks are wider because they've got gaps down the side now for handling all of the cable, all of the IT cable, which gets in the way. And you'll see some horrible pictures in a moment about that. This is an empty racks room before we filled it with racks. And you'll see there are holes in the floor, which is where the wires are going to come up to feed all the equipment. And up here, you'll see some air conditioning. This is pushing cold air around the room. And on the back wall there, that's the power equipment. So this is a fairly small racks room. In fact, it used to be my office at the FBS, and I turned it into a racks room. And we push the air around the room and then down through the racks and these little vents, and it pushes the air round underneath this raised floor to keep all the equipment cool. And the design of that is really quite complicated now, but necessary because racks generate an awful lot of heat. So this is a racks room, that's the same one, but now populated with equipment. And you'll see the racks are facing forward to front, with the back of the equipment facing in backs. And the reason is that you want to walk between those aisles and be able to look at the equipment. And a mistake I've seen made is that there isn't enough room between the racks here. And somebody's put a blade server in, which is that deep, and you can't actually get it out of the rack. So make sure you design your racks rooms to pull the worst, longest, biggest piece of equipment in and out.
And let you still take it in and out, because there's no point having the server be able to come in and out if you then can't reach it to be able to unscrew it and get it out.
And the way the air flows in racks rooms is important as well. The air normally blows down into the floor and out. Otherwise, you'll be sucking the dust up through all the equipment, and all the fans in the equipment will just get full of dirt and dust. This is a slightly different design of racks room where all the cabling is coming through the high level. There's a cable tray at the top there. All the cable runs down into the equipment. And under the floor, there are no wires at all. That's just for ventilation. And the other thing about this racks room is this is called a zoned rack. So there are 5 racks on the left-hand side. You can't see 5 racks on the right-hand side, but they're then enclosed in their own air-conditioned environment. And that separates that piece of rack from some racking next door, which might have some very loud equipment in. I will say one thing is that racks rooms are really unpleasant places these days. They're really noisy and horrible, because particularly blade servers have very high-powered fans running and screaming away like a banshee, and it's a very, very unpleasant place to be.
They're not designed for people, but they are designed for equipment. So when you have to work in them, then sometimes you use protective equipment like earplugs. Ear defenders or something similar. But then obviously there's difficulties with that because you still need to be able to hear fire beacons, fire alerts and things like that. So we don't tend to try and spend too much time in them. If you need to do a lot of work on a piece of equipment, ideally you take it out and then to a workshop.
The picture here shows some overhead power and the wires feeding down into the racks. And the blue connectors here are the EMO sockets, which are the 16 amp or 32 amp sockets to feed a rack and all the power inside that rack. And as discussed earlier in the studios, at the tops of these racks are the power mains distribution units so that you can manage the power within the rack as well.
This is one of the ones at the BBC. So again, it's again on power, but all the equipment is dual fed. So there's a supply A, supply B. All the equipment we dual power. So that if we lost supply A, everything would switch over automatically. Anything that can't be dual powered, we drive from changeover units, which are themselves dual powered. So that means that, again, if we lost supply A, the changeover unit would be powered by supply B, so the piece of equipment remains powered. And there's also breakers, as we talked earlier about needing a breaker in a studio. So the end of each row, there's breakers for that row. So if something did happen, you're not turning off the entire room, but you are turning off the whole row where there's a problem. There's a generator. The BBC, we have the supply A, supply B, various things, and we also have generators on site because one of our, as I think someone mentioned earlier, one of the things the BBC does have to do is keep things on air in a national emergency. So if we lost the power, we've got generators that will do us for a few hours at least.
And in between the generator and the main distribution unit, there'll be an uninterrupted power supply, which is a big pack of batteries, which is converting back into mains and drives everything. So you've probably got 20 minutes of power on the batteries on uninterrupted power.
About that, yeah.
There's only two types of uninterrupted power supply, those that have failed and let you down, and those that will fail and let you down.
Right, so what is in the racks? So this is a BFBS rack for when Quentin was there. So Tie-line audio codecs, so they're the IP codecs we were talking about before for contributions often. Axio IQ DSP engines, Tie-line IP codecs with an ISDN backup. Comrex access unit for OBs to dial into, that's again an IP one. And then when we're talking about planning your bays, the thing you want to do is plan in some airspace between them. So the white things we saw in the BBC ones, or blanking panels or anything, but what you need is some airspace because this equipment does get fairly hot. You cool it all you want, but still each piece of kit has a certain amount of residual heat. So if we can have a one-use space in between them, then we always would. Because, yeah, frying equipment is not good. This, I think, is slightly, well, okay, it's okay laid out. Sonifex red box, which is a distribution amplifier, an audio leveler. For this one, 7-second profanity delay, because you never quite know what people are going to say. A stereo to mono amp, and then a transmission processor, an Omnia, there. And then we've got Capital, so again, an audio leveler, again, a profanity delay. Emergency audio backup, that's something that we'd take very seriously, emergency material. An ISDN backup to a transmitter, so if something went wrong, you've got a way of getting the audio to transmitter. Ventilation spaces, as we said, audio processor, distribution amp, and then, the web feed. That's a big box.
That's a very old-fashioned audio processor.
That does look quite old-fashioned.
That was the one that was in at Classic FM in 1992. It's used for the web feed. A different sort of processing, incidentally. You process for different audiences. You process differently for FM, differently for DAB, and differently for web feeds.
Yes, which is what we come on to here. So this one, there's a lot more explanation on the next slide, but this is the transmission chain for Radio 3. So each platform of each network has the two boxes at the bottom, which are a DCS 578 and a 978 underneath, and then there's the Optimob, which is the audio processor. And as you know, audio processors can be set to different ways. So for instance, like Radio 1, then all the levels tend to be at a fairly kind of high sustain level, or the audio, it's a quite narrow bandwidth. And then for Radio 3, for instance, there's, there are highs, there are lows, and it's meant to have, sorry, yes, ow, this thing is itching me.
I presume that Radio 3 will do different processing at different times of day as well.
It does, to a certain extent, yes. So, I mean, even Radio 3 in drive time will compress the signal slightly so that the idea when people are listening in their cars, of course, because of the road noise, etc., and the other noise, they need to have a bit more of a constant level. And then things like the proms would have a massive dynamic range because, people want to hear that as if they were in the hall often. And you do, for something like Radio 3, you have a lot of very professional, careful listeners, I'd say, who tend to complain if they feel that it isn't being treated with respect.
What I used to call the listeners with their ears 6 foot apart.
Yes. And everything is duplicated in 2 apparatus rooms, in 2 fire zones, so that if there's a problem in one area, there's something else. And that is what you really want to be able to do if you're kind of a professional broadcaster. So this was just a quick look at the transmission chains, so what the boxes in the previous one did. So we've got the 978s here, which are our transmission shelves, and then the Optimob was the processor, and then there's some watermarking, and so you can go in from a network switcher. So that's essentially the studio via a network switcher will go into a transmission chain. If there's a problem, emergency material can be put into there. There's also other inputs which are mostly not used. But it means that if there are any issues in the studio, then there's emergency material that they don't have to play in themselves that gets automatically inserted after a set amount of time. So for Radio 1, that's 30 seconds, but for Radio 3, that's 90 seconds, because otherwise it would just be a pause between movements. And then we have the 578, and you can see from all the various lines about the comparison. So what they do a lot of is comparing the audio on the 2 paths. So from the 2 duplicate transmission chains in the 2 separate buildings, 2 separate fire zones, they do comparisons. So if there is a problem, with any part of the chain, there's an automatic switchover, and that's to maintain broadcasting. So pretty much everything we're doing is to try and maintain broadcasting and not have silences, not have gaps. If there is a problem, automatic changeovers to something else.
Okay. So in a racks room, you will want some monitoring as well, and you want access to all of that equipment. You don't just hardwire all the equipment together and shut the doors and go away. You need to be able to listen to that equipment at every point in that chain to make sure that you can isolate a problem or find out where a fault is. So you'll find in a racks room something like this, a couple of PPM meters, some selection buttons, and a little volume control to power some headphones or a loudspeaker. And you use that together with a jack field here to go looking around for signals and tracing the signal all the way through the transmission chain. You can also, these days, have digital audio, AES audio we call that, and you can have digital versions of these meters, but they cost a little bit more money than good old analog ones. And if you get into television world, you can add a naught onto everything. There are differences with types of meters. You'll see PPM meters and VU meters and various flavors of those. I found this picture on the internet. You can write that down if you're very quick and download it, but we'll sort it out for you later. This tells you the difference between types of meters that you'll find in the broadcasting world and the levels and what they call zero level and what is the maximum level before it all starts to get distorted. You'll also find, certainly in older racks rooms, you'll find jack fields. And these are, again, telephony based. They go back to the telephone days. And you'll find rows and rows of these jacks. They're called B-type jacks. And every piece of equipment is wired into the jack field, and every piece of the inputs and the outputs all feed through the jack field. The clever thing about the jack field is that if you had, for example, a processor feeding a jack, you could listen to that processor there, and then without having any plugs in the jacks at all, the audio would pass through these jacks onto the next place in the broadcast chain. And if you needed to bypass that processor, you could plug something else in here, and it would push the signal of whatever you've plugged in off to the destination. So it's a very clever way of doing monitoring and of bypassing and patching signals. It's very common in radio and TV stations, but it's gradually being replaced by something else. This is a jack field in global radio. In that picture there are 110 rows of jacks. There are 32 jacks per row. Every single jack has got either 2 or 4 wires, and they have to be wired back to somewhere so that you can then wire them onto the equipment. That's 14,000 wires, potentially, with a lot of colour coding and a lot of connectivity. How do you connect them?
Chrome frames. So, very glamorous looking, very useful. Often on the side of apps rooms, rather than actually in bays. So they require no soldering. It's just a chrome tool that you can push the wires in. They were developed again for telecoms and adopted by broadcast in the 80s, still used now. Very good for analog audio, but not just for analog audio. And this is a quite neatly wired one. In the next slide,
That's not a neatly
really
wired
not
one.
what you're after. Because, and the other thing, I know this isn't exactly on keeping records, but it is massively important to keep good cable schedules and keep good records. Because what you bodge in, going, oh, we need that by tomorrow. I'll just do a little bodge for that now, and I'll document it later. About 7 years later, someone will go, oh, that thing that we're still using, how is that done? Or you'll need to remove it, or you'll need to reverse it, and the person isn't there, or they can't remember, quite frankly. And so keeping records of what you've done and where all the cables are and what the cables are for is just, I can't stress how important that is.
And you always find on a chrome field bits of paper stuck in like that saying do not use.
Or, do not remove initials of somebody who left with a date 12 years earlier. And you're going, why? What is that for?
So it's really important to keep your records, and there's something on software called a Chrome Keeper, which is your records for every single wire on every single connecting block with every single colour of that wire. And as long as you keep those records up to date, you will keep your chief engineers and your technical directors very happy indeed.
And you happy when you're not having to go and trace cables.
And you'll be familiar with colour codes on Ethernet plugs. And the colour codes on an Ethernet plug, there's a blue and a white, an orange and a green and a brown and a white. That again is telephony. These are telephone wiring colours. And in broadcast, we use lots and lots of pairs of wires. So this is the first 25 pairs of wires, which start off always in a sequence of blue, orange, green, brown, slate, and then the tracer wire for the first 5 is white, for the second 5 is red, for the third 5 is black, for the fourth is yellow and purple. And if you're very good, you can come up with a mnemonic to remember your colour codes. And I've always used bog brush, blue, orange, green, brown, slate. And to remember the tracer wires, I do rebel yelp. Don't ask me why. Rupert has a different acronym for this, but you get that into your brain and you can wire up one of those crone fields in no time at all and make no mistakes. IT wiring is different and is messy because you tend, or used to tend, to bring all of the IT equipment out onto its own jack fields, effectively, the strips and strips of connectors, of Ethernet connectors, and then you patch them with all these cords to join them together, which makes a right mess. But thankfully, that's getting a bit better now. With the top of a rack, you tend to have a switch and you'll fibre to the other racks, and we're beginning to lose that kind of rat's nest of IT wiring, but it'll never go away. And there's nothing quite like, there's nothing that the equivalent of crone and jack fields for IT wiring yet that I'm aware of, but there may be. Mm. So we haven't got much time left. We're going to do a demo, but we'll explain a little bit about delay in audio, because all of this digital equipment that's in your rack causes a delay between the voice hitting the microphone and it coming out the other end. And one of the biggest problems is people listening on headphones to their own voice after it's been through a whole load of digital equipment. And all of these kind of bits of equipment can delay the signal by something or other. So if that delay is more than about 10 milliseconds between your mouth and coming back into your ear, funny things happen in your brain. And we've got a demo there, but what I'm going to do is set that up so that people can have a play with it themselves later on. We won't do it now.
We can do it.
You have got time. OK, we'll set it up now then, and we'll call on a willing victim who has volunteered, and you'll hear what happens when you have delay between your voice and your ear. And it's one of the things that one has to be careful of when you're designing radio stations as a whole, but obviously all the equipment that's in a rack room. I'll just put on the next slide and so you get an idea of the types of delays that you get in digital equipment. So sound travels at 1,000 feet per second, about 300 meters per second. So I'm about 20 feet from you in the middle there, so my voice is taking 20 milliseconds to get from me to you. Anything more than about 10 milliseconds between your voice and your own ear, because the voice is traveling through your bone of your skull as well, your brain starts to get very confused by it. Other kinds of equipment have much bigger encoding delays. So if you encode with a modern AAC algorithm, it's about 300 milliseconds. If you fire signals up to a satellite and back down, that's just about a quarter of a second. Apollo 11, 50 years ago next week, it took 2.8 seconds for the voice to go from Houston up to the moon and back again. A cell phone has about a quarter of a second delay in it. A BBC Sounds app takes about 60 seconds from the sound leaving the studio till it arrives on your iPad. And one frame of a TV signal is about 40 milliseconds of delay. So they're all bigger than that magic 10 milliseconds. And that's where you can get into all sorts of problems. So what we're going to do now, would you like to come out and be my victim? What we're going to do is put a pair of headphones onto you. And you're going to speak into a mic and you'll hear yourself coming back on the headphones. But then I'm going to delay the signal coming back into his headphones, and you can hear what happens as you read from this very good book, which is in your pack.
You can already hear the delay.
So, hang on. Let's exit that delay.
Yeah, probably needs the mic.
You'll need to speak into the mic. Hang on. Right, if you speak into the mic, and you should be able to hear yourself.
Yep.
Okay? Do that.
How annoying is it to be grabbing the TV remote all the time to turn the sound up and down? The continuity announcers are barely
I'm now building the
on
delay out in his earphones.
Show credits, while the ad seems louder than anything else. Whatever the rules are supposed to say, TV forks really don't get sat.
You see the problem. So make sure that when you're planning any of this that you don't allow delay to get back into a presenter's headphones. Thank you very much indeed. Thank you. Another source of delay is TV cameras in studios. We talked earlier on about the TV cameras, and you're going to be taking the sound not from the microphone on the camera, you're going to be taking the sound that's come through all your broadcast chain. And by the time you try to marry those two up again and put the sound back in with the TV picture that you're sending off to the web, they will be out of sync. So you have to get them back into sync using delay machines a bit like that in your racks room before you recombine the audio and the video, because they've gone through entirely different paths. And it's something that catches radio engineers out, because we don't understand pictures, we understand sound. And the pictures have their own delays and their own technologies, and it's something that one has to grapple with until you get to a point where you're, as somebody said earlier, you're building a radio studio and the TV pictures are secondary. If you come from the TV world, the pictures come first and the sound comes second, which is why TV sound is always rubbish. But in the radio world, radio comes first and the pictures are secondary. They're not needed because we paint better pictures in people's head with better resolution and better colours than anything that a TV camera can do.
We do. So, Master Control Room, I wanted to put a picture up really of the control room at the BBC. So this is essentially, it's kind of why you need an MCR if you're a larger broadcaster. And it is essentially the brains between the studios and the transmission. So you've got the kit in the racks rooms, you've got the people in the studio, you've got the guests and all the presenters, and the people in the control room, but what they don't have then is kind of any glue between them. And that's fine if you're a small station that has kind of one output, but if you're something like the BBC with 10 national radio networks, with the World Service with about 40 language radio networks, plus some TV, plus your TV news channels, etc., you need something else. So, essentially what we do here is we bring in, on the contribution side, we bring in the contributions for the TV news, so the correspondence you see on the TV, on News 24, well not News 24, News Channel now, and World TV. So somebody, Laura Koonsberg, reporting from outside something, has come through the MCR to be set up. And it's exciting as well. You know, you chat to her, you get it all set up, you get the clean feed working, you see her on air. You feel like you've made a difference. From the radio point of view, again, when we connect the studios in Salford or the outside broadcast, the proms from Glastonbury, the festivals, Wimbledon, all those things, they all come through and we package them up, we set them up, we get the lines together, clean feeds working, talkbacks working, everything else, reserves, always reserves, different paths, different things, so that we can get all that in, tested and ready to pass to the studio. What we don't want to do is make the people in the studio's job any harder. They have an awful lot to cope with when they're doing a live show. They just need to have something presented to them that works. And the other thing we do then is look after the distribution chain, look after what happens from the studio. So our responsibility is all the switchers, the transmission chain, all the central area systems. So what these screens here again are obviously controlling equipment that's in racks rooms. The talkback system that goes around the building and lets people not just talk between different areas, but also to their outside sources, to their guests outside the building. All of those things are the responsibility of the people in the MCR. So that's staff 24/7. Whenever whatever you're doing, you're on a beach, you're asleep, you're having fun with your family at Christmas, there are people in that room there providing not only the connectivity but also the expertise to the whole organisation, to all the people in the studios as the point of contact. So, yeah, so really as your kind of stations expand, there are more things to think about putting in place.
There are different names for MCR. Some people call them a mixture of names, but you'll come across MCR, Master Control Room, NOC, Network Operations Centre, and every variety of acronym in between, I'm sure.
And we've been called most of them, to be honest.
So there we are. Hope you enjoyed that. Any questions that are arising from that we can help you with? I think we're going to make these presentations available to you, and there are some notes on our presentation behind that with a little bit more detail. But I have to go around and black out all the IP addresses on the pictures of the codecs, I'm afraid. Sorry about that.
How do you... I hear all the time that the best way to get into radio is through volunteer radio stations, hospital radio stations. I never hear how you get on from that into the next level. How did you move on?
Well, this was a long time ago. This was way in the last century. And I did work in hospital radio, and then I kept knocking on the door of a commercial radio station until they let me in. And I became a tech op. I was still at college at the time, and then they took me on full time. So that was my lucky entry, and that's not an uncommon story. But with schemes like the BBC apprenticeship scheme now, that's a really great way to get in, because the graduate apprentice, and then there's the...
there's the people we take at 18 who essentially get a degree at the end of it, plus obviously the training.
Or a BTEC.
And then there's a BTEC, and then there's the graduate scheme where we take graduates and they go through a master's scheme as well as a training, and then they can apply for all the BBC jobs at the end. And you'll hear more about those this afternoon because one of our nearly qualified trainees is here with us.
Could you possibly just outline the brief overview of how the sound gets from the microphone to the transmitter, just in terms of which machine does it go to, in what order?
Every station is different, but let's sort of take a typical radio station. So from the mic, it will go into the audio mixer. The audio mixer could be an analog mixer, therefore it will go through the desk in front of you. If it's a digital mixer, your mic is probably fed to a central racks area and going into an interface engine of some sort. The output of the mixer with all the other sounds joined to it will then go probably to some kind of a processor, an audio processor, to get the levels right. It will then probably go to some sort of changeover system, so an emergency feed to back up to the transmitter. We showed those on one of those slides, which was an ISDN codec to dial up, or something that if the studio fails will carry on sending some audio. You will then have wrapped around that some kind of routing system, so switching so that you can divert studios to one transmitter or to a radio station, or another studio to another. They can be small, they can be large, they can be run by a master controller, or they can be run by the presenters themselves on some kind of switching selection panel. Once it's gone through essentially that equipment in the racks room and monitoring points and all the other little bits and pieces, you will then feed it down some lines or some kind of a link off to the transmitter. The transmitter in commercial and BBC stations is never in the radio station. It's always up on the top of a hill somewhere. In a community radio station, the transmitter might be in your own building, but if your transmitter is distant, then you'll need to feed your transmitter through some lines that you buy, either telecom lines, or more likely these days it'll be an ADSL or an IP of some sort. But you may also do it on a radio link to your transmitter. So that's the kind of the linear path, and then everything else that's bolted on is just to fancify the signal or to provide more monitoring.
Or to split it off to different platforms. So for instance, we have FM, DAB and DVB, which is digital TV and radio. TV. So and DSAT. So our signal past we have the network switcher and everything, and then after that it gets split off. So the transmission shelves I showed you earlier, we have separate ones for each platform, and then they go and be coded and multiplexed. So the BBC does its own DAB coding and multiplexing, and then that gets transmitted.
And I was looking, when I was putting this presentation together with Charlotte, for schematic diagrams to do exactly that. Every schematic diagram I came across didn't include a racks room or a central control. It was studio equipment, transmitter. That's all you need. And actually, that's not true.
Thank you very much. I'm afraid that's all we've got time for questions. But again, please do come and find them later. Thank you.
Thank you.